How does Epstein-Barr virus trigger MS? Have you ever wondered how a common virus could be linked to a complex disease like multiple sclerosis? Multiple sclerosis, or MS, is a chronic autoimmune disease where the immune system mistakenly attacks the protective coating around nerve fibers in the central nervous system. This damage can lead to a variety of neurological symptoms. One virus that has been closely studied in relation to MS is the Epstein-Barr virus, or EBV. EBV is a common herpes virus that infects more than 90% of adults worldwide. Research has shown that being infected with EBV significantly increases the risk of developing MS. In fact, individuals who have had EBV are over 30 times more likely to develop MS compared to those who have never been infected. Interestingly, MS is extremely rare in people who remain EBV negative, suggesting that EBV infection is a necessary factor for most MS cases. A history of infectious mononucleosis, which is a symptomatic infection caused by EBV, further raises the risk of developing MS. So, how exactly does EBV trigger MS? One key mechanism is known as molecular mimicry. After an individual is infected with EBV, the immune system produces antibodies to fight the virus. One of these antibodies targets a viral protein called EBNA1. However, some of these antibodies can mistakenly recognize a similar protein in the central nervous system called the glial cell adhesion molecule. This cross-reactivity leads the immune system to attack the body's own myelin, which is the protective sheath around nerves, resulting in the nerve damage characteristic of MS. Moreover, EBV has the ability to infect and persist in B cells, which are a type of immune cell. This persistent infection can lead to chronic changes in immune function, promoting inflammation and autoimmunity in individuals who may already be genetically susceptible to MS. While researchers are still working to fully understand how EBV alters immune responses to drive MS progression, it is clear that the interactions between the virus, immune activation, and genetic factors are complex. In summary, EBV triggers MS by preparing the immune system to attack myelin through molecular mimicry and by causing long-term changes in immune function that promote inflammation. This understanding of the link between EBV and MS opens up potential new avenues for prevention and treatment, such as vaccines aimed at preventing EBV infection or therapies targeting EBV-infected B cells. However, it is important to note that EBV infection alone does not cause MS. Other genetic and environmental factors also play a role in the development of the disease. For individuals living with MS or those at risk, this research highlights the importance of ongoing medical care and the potential future role of antiviral therapies or vaccines in managing MS. Always consult healthcare professionals for personalized medical advice and information.